Hello, I'm glad to welcome all the participants of the conference. My name is Tetiana Nikiforova, and for your attention is a report on construction technology for affordable housing with the use of space-braced concrete filled steel tubular framing. At present, buildings from monolithic reinforced concrete in shallow and large panel formwork are erected using large block and frame construction technology. Volume of brick, panel and frame panel house construction has declined strongly. Expansion of monolithic framing house construction causes considerable capital investments connected with frameworks, depends on weather conditions. It is characterized by big material consumption and accordingly construction cost and terms. Concrete filled steel tubes possess extremely high bearing ability, here with having significantly less cross-section of a column. It is a bright example of complex materials that combines optimally strong sides of concrete and metal. Metallic shape functions as a permanent formwork in a CFST column, and after concreting process, it reinforces the column either in cross or longitudinal direction that allows to meet any loads applied at any angles. Concrete in such a column is an optimal state for itself. All around compression, and in such a condition, it withstands load significantly exceeding its prism stress. Reconstruction of residential buildings demands special attention to choose engineering solutions in the improvement of volume constructive solutions and provision of operating factors with the demands of present regulations. According to the present constructive solutions, there are three types of superstructure. General, without strengthening a present building. Superstructure is a high extension of a building saving its constructive scheme. It allows 2 to 3 additional stories. The second one is changing its constructive scheme. The given method suggests redistribution of load transmission scheme from the weight of additional stories and existing buildings on bearing members, loading them equally, allowing additional 4 to 5 stories. And finally, superstructure plans that is not connected with bearing structures of the present building and supports on individual structures. Such a superstructure can be erected over any building. Essentially, with additional stories, their stress is given to reinforced concrete slab located on columns which are located uniformly by the perimeter of a building and support on their own foundations, allowing to add 10 to 20 stories. As concrete filled steel tubes are complex material, there are some difficulties in calculation complex. With this purpose, we use the methods of unit stiffness. Here we section over a shotcrete member carried into an equivalent section of concrete with the diameter by the formula, which is shown on the slide. As a possible variant of using steel reinforced concrete structures in mass civil construction of a new housing or the reconstruction of an old one, There was elaborated the structure of a superstructure of 5-story residential building with the aim of its redevelopment. Its frame consists of CFST members. The structure of a superstructure represents itself as a stack frame with vertical bearing members. It is 2 member columns connected between each other with P-shaped multi-layered frames by Gida system, beams and bracing of shaped pipes of square and rectangular section filled in with concrete that ensures space stiffness of a building in cross and longitudinal directions. Step of portal frames was 6.3 and 8.4 meters and associated with the location of partition walls in the present building. On this slide, you can see the emerging efforts. Loads on the present frame members were taken according to the present regulations. Joint between constructive members of the scheme is presented as pin-connected. Eccentricity of load transmission from a jitter to columns was considered in calculation as well. Strains occurring in the design model are given in this slide. According to national standards of Ukraine, bendings and motions, regulations limited horizontal motion of multi-story building should be at most 100 millimeters according to the calculation results. Minimum bending occurring in a superstructure doesn't exceed 34 millimeters. Mosaic of motions is presented on this slide. In slide 9 are given the parameters of the used CFST frame members. Flooring is made of prefabricated hollow slabs with connectors on lateral areas. Connectors taking main closing strains occurring during the operation of a steel floor in covering can be monolithic. Provision of strain transfer between members and redistribution of locally applied stresses on neighboring slabs excludes key effect proper for flooring structures of prefabricated slabs without connectors on a lateral surface. In conclusion, I would like to say that saving steel at the expense of usage of concrete instead of steel in compression, not only in columns and spandrel beams, but in bracings, filling in with concrete and increasing of local strengths of pipe walls, resistance increasing to local failures of thin-walled steel structures in assembling, 3-dimensional operational framing under horizontal stresses, absence of significant bending moments in columns causing eccentricity in joints as a result of pin-connected spandrel beams with columns, reduce of bending moment in spandrel beams at the expense of bracings, which are like additional intermediary supports. Secondly, reduction of labor intensity for assembling construction terms due to reduced cost of borrowed financial means at the expense of transferring a large number of operations connected with steel structure production from a construction site to a plant. In other words, metal structures production, partial filling in which with concrete. Unification of steel concrete spandrel beams and bracings independently on the location of members by the height of a building. Assembling of prefabricated structures reduced length of weld seams as a result of a pin-connected joint and absence of stiff joints. Finally, reduction of size and cost of foundations at the expense of reduction of total mass of steel concrete framing in comparison with reinforced concrete framing, and absence of bending moment in supporting pin-connected joint of a column and foundation. Okay. Thank you for your attention.